Welcome, Warhammer 40k fans. Today, Billy will continue his transformation from regular boy
I am Iron
into a fully locked and loaded, battle-ready Astartes Astartes.
I am Doom.
I commend him on his toughness, having successfully received 12 of the requisite 19 organs from the aspirant stage up until now. Admittedly, Billy, now 15 years old, has a rough couple of years ahead of him as we bring this extremely complicated physiological ordeal in for a landing. But since the very fate of the Imperium of Man is at stake, it's his only option. The enemy won't show any mercy. We'll consider how the next 3 organs might be adapted or explained with modern medical science. Or, to quote Sergeant de Kestrel of the Raven Guard, "We go where we wilt. We slay who we wilt. Let the Emperor judge the righteousness of our deeds." And now, bring in the melanchromic organ. I was very pleased to find this excellent artwork by First Mage Lord on DeviantArt, featuring several of the organs we will cover today. These interpretations will help us to visualize the remaining steps of the creation process while adding another level of realism to our analysis. In Mage Lord's illustration, the melanchromatic organ is surgically inserted at the base of the neck at the level of the suprasternal notch, the soft space between the collarbones. This space is home to several important blood vessels, the innominate arteries, aorta, and others, as well as our esophagus and bronchi. The tech priests must carefully navigate these critical structures as they implant this incredible organ. Once in place, it will automatically regulate melanin levels in a Space Marine's skin in response to electromagnetic rays from various suns and radiation sources across the known galaxy, which it must also measure. Not as simple as it sounds. Let me explain why. Melanin is an amino acid-based polymer that creates pigmentation in our skin, eyes, and hair. It is formed in cells called melanocytes, a cell in the skin, or more specifically, the layer of basal cells at the deepest part of the epidermis, and in the eyes. Within the melanocytes, the amino acid undergoes an oxidative reaction, which occurs when a substance comes into contact with oxygen. Examples of oxidation are rust and the color of brown on the flesh of a cut apple. Inside our body, this oxidation process produces 2 types of melanin. Eumelanin, which can be either black and brown, and is responsible for dark color in the skin, eyes, and hair, or pheomelanin, on the other hand, that pigments your lips, nipples, and other pinkish parts of your body. The Cleveland Clinic tells us typically all humans have the same number of melanocytes. However, the amount of melanin produced by these melanocytes varies. The more melanin you produce, the darker your eyes, hair, and skin will be. The amount of melanin in your body depends on a few different factors, including genetics and how much sun exposure your ancestral population had. Although the baseline for melanin production and overall melanin levels is predetermined, there is a small amount of fluctuations on a day-to-day basis depending on a person's exposure to UV radiation. A 2011 study from Brown tells us after an hour, measurable amounts of melanin accumulate, although in relatively small quantities compared to the production that will occur within 24 hours. Senior author Alina Onasia, assistant professor of biology at Brown University, elaborates. As soon as you step out into the sun, your skin knows that it is exposed to UV radiation. This is a very fast process, faster than anything that was known before. According to another study published in 2018 in Molecular Cell, this melanin production cycle initiated by temporary exposure to UV radiation is completed after about 48 hours. And as a result, some people have opted not to sunbathe 2 days in a row. In the majority of earthbound situations, where approximately 70% of the sun's radiation is absorbed by the atmosphere, this process offers extra adaptive protection when we are exposed to more radiation than our body has evolved to tolerate. Whether biologically predetermined or generated as a response to exposure, the shielding effect of melanin, especially eumelanin, is achieved by its ability to serve as a physical barrier that scatters UV radiation and as an absorbent filter that reduces the penetration of UV through the epidermis, as explained in a 2009 article in the Journal of Photochemistry and Photobiology. But in space, beyond our protective atmospheric bubble, radiation is a much bigger concern. especially given the size and power of some of the suns we know of in relation to our own. Waging war on enemies of the Imperium necessitates extensive intergalactic travel, where the Astartes will be exposed to a wide variety of solar radiation levels, and thus the ability to generate more melanin is very important. If within our own observable universe there are planets with giant suns or multiple suns at once, the melanchrome is bound to have its work cut out for it in the grimdark 40K universe, where the environments are often extreme. Take Barris Spine in the Calaxis sector, for example, where the sunward half of the tidally locked world of Barris Spain is inhospitable to life. The high winds and heat can scorch a man to death in a matter of hours. I wonder what the radiation is like there. No matter how skilled the warrior, if they are struck with acute radiation syndrome, they stand no chance in battle.
You betrayed me. You betrayed.
If my melanchrome was working, I would have had him. This affliction, also known as radiation sickness, begins to get serious 5 or 6 hours after the initial radiation exposure. Tremors and convulsions will begin, and eventually coma and death are inevitable within 3 days. Radiation exposure is often measured in gray units, one of which is enough to cause radiation sickness, while 4 gray units is the LD50, and you know what that means. I will spare you the details, but suffice it to say that exposure to high levels of radiation will damage the DNA within your cells. The Space Marines would also be susceptible to cutaneous radiation injuries, or CRI, which really are not very pretty. Google to see more severe ones at your own discretion. A doctor will suspect the presence of a CRI when a skin burn develops on a person who is not exposed to a source of heat, electrical current, or chemicals. Symptoms of CRI can appear from a few hours to several days after exposure. But similar to ARS, a single high dose of radiation could be all it takes to trigger it. If you have the misfortune of being caught in a blast like Chernobyl, the effects will be more acute, but radiation can be potent even after the initial radioactive event. Just ask the liquidators, the civil and military personnel who were called upon to deal with the consequences of the 1986 Chernobyl nuclear disaster in the Soviet Union on the site of the event, among whom death and disability rates have soared over the years. All this is bad news for the melanchrome, since by the time the skin has detected radiation and the aforementioned adaptive process has begun, DNA damage may have already occurred. Those signs may begin to show later. In some applications, the melanchrome would need to be activated preemptively, initiating the melanin production cycle before the Space Marines were exposed to environments with severe radiation. Unless, of course, they enjoy the exposure.
It's about 130 degrees in here, that's like 50 degrees Celsius.
We'll assume the melanchrome is capable of producing the necessary hormones, and its location at the base of the neck enables it to deposit said hormones directly into the major blood vessels for rapid transportation around the body. A potent dose of synthetic hormone could bypass the master regulator of gene activity, which sets skin cells to make melanin every 48 hours. And we know that large amounts of melanin can accumulate in a time frame as short as an hour. But even that would be too slow. Maybe over thousands of years, the Imperium of Man was taking notes from the chameleon, who are able to manipulate their color by controlling the dispersion of pigments contained in skin cells called chromatophores. An article on Wired explains, normally the pigments are locked away inside tiny sacs within the cells. Perhaps, like the chameleon, the melanchrome triggers the dispersion of pre-existing melanin cells contained in genetically altered melanocytes until increased pigmentation is necessary. The chameleon's chromatophores offer an excellent example of how this may occur. Tiny organs that are present in the skin of many cephalopods, such as squids, cuttlefish, and octopuses, which contain pigment sacs that become more visible as small radial muscles pull the sac open, making the pigment expand under the skin. If melanin levels are not regulated properly, according to the American Academy of Dermatology Association, an individual may end up with too much melanin, which can lead to skin conditions like melanasmas or hyperpigmentations. This could be a potential risk for a Space Marine who may have a poorly integrated melanchromatic organ. But what are skin spots to an advantage in regards to interstellar travel? Some studies suggest there may be other benefits as well. These studies show that cancer rates are lower for individuals with more melanin in their his skin. I guess the salamanders were onto something. All right, Billy, let's keep moving.
Go, go, go. Who's next? Go, 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 go.
The oolitic kidney improves overall blood flow and acts in conjunction with the Space Marines' secondary heart to filter powerful toxins out of the bloodstream. According to the Warhammer Lexicanum, there is a trade-off, since emergency detoxification usually renders the Marine unconscious while his blood is circulated at high speed. We've already covered poison filtration at length in part 2 of this series, in relation to the preomnur and the multilung, which are the Marines' primary lines of defense against poisonous substances. I'll quickly recap what I explained in that video. There are innumerable types of toxins that affect the human body in many different ways, and it is beyond the capacity of modern science to neutralize every substance a Space Marine might encounter. It is also difficult to remove a powerful toxin once ingested, in the case of the preomnur, or inhaled, in the case of the multilung, because the tissues that make up our digestive and respiratory tracts are both porous, offering many chances for the poison to enter our tissues and bloodstream. This simple fact necessitates the alteration or replacement of every part of the system with a non-porous material wherever this transference could occur. As you'll see, both of these facts complicate the proposed function of the oolitic kidney to a greater degree than the multilung and preomnur. Before we go any further, we'll need to understand the basic function of the kidneys.
I'm sorry, sir. What is this? It's a kidney.
Naturally, we have 2 kidneys, and their main job is to
Purge the unclean.
excuse me, cleanse the blood of toxins and transform the waste into urine.
I'm a doctor.
The toxins to which I am referring here are not particularly potent, nor are they present in lethal amounts. Typically, as explained by Joseph Pizzorno in the Journal of Integrated Medicine, we're talking about unwanted products of metabolism, such as ammonia, urea, uric acid, creatinine, end products of hemoglobin metabolism, and hormone metabolites. Toxins that may have been made water-soluble by phase 2 in the liver, and direct excretion of industrial toxins, such as heavy metals and a number of new-to-nature molecules. They also excrete nutrients or food constituents when consumed in excess, such as salt, vitamin C, B vitamins, and others. In a way, these fist-sized, bean-shaped organs are tasked with regularly taking out the trash. But, and this is important, said trash would not kill us immediately if the kidneys forgot to do their job, or if their function was impaired. I would imagine the poisons used within the Warhammer universe are far more dangerous than the toxins to which our kidney regularly attends. And this is where it gets hairy. No amount of improvement to the function of the kidney would shield the body from the effects of a very potent toxin for 2 main reasons. Number 1, the kidney does not filter blood before it arrives to the heart. It does so afterwards. The heart pumps blood to many areas of the body all at once, and only some of it is directed to the kidney for filtration. Imagine, if you will, a Space Marine locked in combat with a Skaven warrior sustains a wound from a poisoned blade. The poison seeps into the damaged muscular tissue and subsequently enters the venous bloodstream, which transports it to the heart. No matter what structure the poison is designed to affect, the heart muscle is poised to transport it there. Neurotoxin will travel through the carotid arteries to the brain. Paralyzing venom will work directly on the muscles at the wound site and of the heart. A virus that attacks connective tissue will travel to the extremities, and so on and so forth. Perhaps this is why the Marine is rendered unconscious when the oolitic kidney activates. See, the circulatory system is a simple loop which starts and ends with your heart, specially devised to deliver oxygen to the tissues that make up your body. Maybe because this is a closed system, meaning blood does not enter or leave the system during its journey from your heart to your body and back again, it can be altered to quarantine toxic compounds within the loop. Theoretically, this could be achieved with synthetic valves placed at strategic junctures throughout the circulatory system, used to temporarily close connecting vessels to affected muscles and organs. This would mean that for the duration of the filtration procedure, the organs outside the chain are deprived of oxygen. So let's consider how long tissues can survive in severely hypoxic conditions. We need look no further than a 1998 article published in the British Medical Journal on tissue hypoxia. Brain, less than 3 minutes. Kidney and liver, 15 to 20 minutes. Skeletal muscle, 60 to 90 minutes. Vascular smooth muscle, 24 to 72 hours. Hair and nails, several days.
When will she be ready? When will she be ready?
Too bad they need a brain. Guess that means we've got 3 minutes to thoroughly filter all the blood contained in the human body. The amount of blood circulating within an individual depends on their size and weight, but the average human adult has nearly 5 liters of circulating blood. Space Marines would have more than that due to their size. While our kidneys are capable of filtering an impressive 200 liters of blood each day, removing 2 liters of toxins, wastes, and water in the process, this only equates to about half a cup, or 0.138 liters of blood every minute.
That's a lot of blood, guys. That's a lot of blood.
After 3 minutes, we wouldn't even be halfway there. But hold on. Before we even begin to speed up the rate at which the heart is pumping blood to the kidneys, we must contend with the fact that if the heart is pumping poison blood, it too could be affected by the poison. Anything designed to paralyze, degrade, or kill cardiac muscle and connective tissue will do the trick, since that's what the heart is made of. Similarly, the arteries and veins will be exposed to poison in this process, as they too are comprised of muscle and connective tissue. And although the walls of blood vessels are equipped with a water permeation barrier that keeps leakage to a minimum, they serve as a semi-permeable barrier between blood contents and the tissue, which is much more permeable than epithelial systems. For these reasons, I think a reorganization is in order. Firstly, I propose we put the oolitic kidney before the heart, allowing it to filter blood prior to its distribution around the body. To some degree, this rearrangement would allow us to quarantine a virus or toxin between the site of the wound and the venous portion of the circulatory system, between that location and the oolitic kidney before the heart. An article in Biomaterial Translational Journal tells us many artificial blood vessels have already been shown to possess adequate performance. However, they are still unable to meet usage requirements in terms of long-term patency rate and thus require optimization. These structures deploy non-degradable polymers, biostable polymers, such as expanded polytetrafluoroethylene, EPTFE, and polyethylene tetraphthalate, PET, are currently the standard biomaterials for vascular grafts in clinical applications. If the right materials could be found, and we could find a way to simulate the rhythmic movement of smooth muscle in the vessel wall, we could use poison-resistant synthetic veins to solve our porosity issue. Of course, this would require the replacement of many of the major veins, but at least we are able to avoid the arteries. And then the kidney. It still needs to be more powerful, especially in its new location where it will now be dealing with a much larger supply of blood without the powerful heart muscle to pump and pressurize that blood to any great degree. You see, blood flows into your kidney through the renal artery, branching into smaller and smaller blood vessels until it reaches tiny filtering units called nephrons. Approximately 1 million of these filtration devices make up the kidney. They work through a two-step process.
No, not again.
The glomerulus filters your blood, and the tubule returns needed substances to your blood and removes waste. Much like the filters we use around the house, the thin walls of the glomerulus allow smaller molecules, waste, and fluid, mostly water, to pass into the tubule, while larger molecules such as proteins and blood cells stay in the blood vessel. The main driving force for the filtering process, or outward pressure, is the blood pressure as it enters the glomerulus. But the venous side of the circulation is a very low pressure system compared with the arterial side. Pressure within the named veins is usually between 8 and 10 millimeters of mercury, and the central venous pressure is 0 to 6 millimeters of mercury. Contrast this to the systolic blood pressure, which is defined as the maximum pressure experienced in the aorta when the heart contracts and ejects blood into the aorta from the left ventricle, which is approximately 120 millimeters of mercury. Blood primarily moves in the veins by the rhythmic movement of smooth muscle in the vessel wall, and by the action of the skeletal muscle as the body moves. Because most veins must move blood against the pull of gravity, blood is prevented from flowing backward in the veins by one-way valves. But I doubt that any amount of venous pressure would be sufficient, and the oolitic kidney would need to be equipped with some sort of fluid suction mechanism and/or a pump. Currently, the Kidney Project is working on a bioartificial replacement as a permanent solution to kidney failure. The company predicts the first generation of devices in 3 to 4 years and tells us the first first versions of the device will not provide as much kidney function as a transplant or a healthy natural kidney, but enough to keep patients off dialysis. Unfortunately, our Marines are going to need more than that, so I'll be sure to let them know that we'll need something 10 times as strong with a built-in suction and pump mechanism. The next organ we will be examining here is the neuroglottis, also known as the devourer, which helps to enhance the Space Marines' sense of taste to the point where they can track an enemy by taste alone. As stated in the Warhammer 40k wiki, the organ is implanted within the Astartes' upper nasal passages, and after it is functioning, chewing, tasting, or smelling a substance allows a Space Marine to biochemically test it for toxicity and nutritional content, essentially determining if the substance is edible or poisonous. Is it just me, or do Space Marines have a thing for poison? Need I remind you, many toxins easily pass through the lining of the mouth and into the bloodstream. Is there no other way to test a substance for toxicity other than ingesting or smelling it? But I dare not question the Emperor of Mankind. For many of us in modern day, taste has been regulated to a pleasurable sensation, picking and choosing as we meander the aisles of a grocery store. Evolutionarily, of course, its role was more survivalist in nature, enabling the evaluation of foods for toxicity and nutrients while helping us to decide what to ingest, as it prepares the body to metabolize foods once they have been ingested. But let's not get the wrong idea. An early Homo sapien bumbling around sampling everything that looks out of the ordinary would likely remove himself from the gene pool. Instinctively, we know that taste and smell are closely connected. You need only sample your favorite dish while your sense of smell is impaired. That's because only the taste, not the food odors, are being detected. Taste itself is focused on distinguishing chemicals that have a sweet, salty, sour, bitter, or umami taste. Umami is Japanese for savory. Brainfacts.org sums it up succinctly. Taste and smell are separate senses within our own receptor organs. Tastants, chemicals in foods, are detected by taste buds, which consist of special sensory cells. When stimulated, these cells send signals to specific areas of the brain, which makes us conscious of the perception of taste. Similarly, specialized cells in the nose pick up odorants, airborne odor molecules. Odorants stimulate receptor proteins found on hair-like cilia at the tips of the sensory cells, a process that initiates a neural response. Ultimately, messages about taste and smells converge, allowing us to detect the flavors of food. Technically, flavor is defined as the particular way a substance, especially food or drink, is recognized from its taste and smell. That is to say, what results when the brain integrates both taste and smell information. Obviously, these independent senses can function independently, and in modern Space Marines, I would advise we keep it that way. A 2012 article from Progress in Molecular Biology and Translational Science states, if taste is the gatekeeper, the sense of smell is the sentinel, evaluating the food for danger before it enters the mouth. To the trained tracker, this practical application of smell is elementary knowledge. Just ask expert tracker and survivalist Jake Kassar.
Also, don't forget your nose. Someone might have been lost for a while, but they've got a lighter and they've got a campfire. That smell is going to travel uphill better than downhill, so if you're up on the high ridge.
A 2017 article corroborates this ability for military use, stating, Olfaction as a Soldier, a review of the physiology and its present and future use in the military, focuses on military application for taste. So this idea of taste as a strategic tool is really not new. And Space Marines in the year 40K are the evolution of this idea. One study the point makes is olfaction plays a major unseen role as an innate alarm. It could also be used as a means to gain a significant tactical advantage over the enemy in the battlefield, as it is still a relatively underrated and underdeveloped but potentially powerful qualitative sensory ability. For the average person, there are very simple ways to enhance our sense of smell. Avoid anything that damages the odorant sensitive receptors mentioned above, harsh chemicals found in cigarettes, alcohol for example. Introduce the practice of paying attention to the smells you encounter and familiarize yourself with the nuances therein. But I doubt our paragons will be allowed to smoke, and I can't envision these guys walking around with a scent diary. They've got business to attend to. Maybe we can take some notes from man's best friend, with a sense of smell up to 100,000 times better than humans. So sensitive that a dog can detect the equivalent of a half teaspoon of sugar in an Olympic-sized swimming pool. So Dr. Michael T. Napier of Virginia College of Veterinary Medicine told PetMD. Another article from the Phoenix Veterinary Center tells us dogs possess up to 300 million olfactory receptors in their noses, compared to about 6 million in us. And the part of a dog's brain that is devoted to analyzing smells is about 40 times greater than is ours. Right, so more nerves and more processing power devoted to the sensation of smell. Similarly, sense of taste is determined by the amount of taste-sensitive cells and processing power allocated to taste interpretation. In this realm, dogs and cats are comparatively weak, whereas the catfish has up to more than 175,000 taste-sensitive cells, as compared to an average person with only 10,000 taste buds located in its entire body. Interestingly, a 2012 article in Current Opinions in Otolaryngology, Head and Neck Surgery explains cells within the olfactory epithelium, or OE, have unique regenerative properties, including the ability to undergo neurogenesis and replace olfactory neurons following injury. Over the past 2 decades, the survival and regenerative capacity of olfactory tissue has been studied after transplantation to different parts of the central nervous system. Apparently, recent studies have shown that the olfactory epithelium can be grafted directly to the olfactory bulb. Let's take a closer look at what that means. We're taking cells from the inner lining of the nose, olfactory epithelium, and implanting them in the olfactory bulb, a rounded mass of tissue that contains several types of nerve cells that are involved in the sense of smell, on the bottom side of the brain, above each nasal cavity. Perhaps this process could be used to enhance a healthy sense of smell by increasing the amount of brain space designated to olfactory interpretation. Maybe scientists can use a similar technique to increase the number of papillae in the tongue. Papillae are the little bumps on the top of your tongue that help grip food while your teeth are chewing and contain your taste buds. Some speculate the taste may also be enhanced through the use of electrical stimulation to the tongue, which can increase their overall sensitivity. In the near future, gene therapy may also be used to increase the number of taste receptors on the tongue, and brain-computer interfaces to directly stimulate the brain taste centers. These methods are still in the early stages of research, but give it 38,000 years and progress shall be made. All right, interns, that's it for today's video. With a little luck, we'll conquer the final couple of organs in our next installment. Remember to follow my online gym Human 2.0 for free right here on YouTube, where we help you prevent injury and move better. If you liked the video, be sure to subscribe and give it a thumbs up. If you didn't, be sure to let me know why in the comment section down below. And as always, that's been a word from Dr. Chris, not your everyday ortho, where we see one, do one, teach one.